So I see people joining. Hi, everyone. We give a couple of minutes so that more people joins and then we get started.
I think the real question is how do you know that we're not AI agents?
That's a fair question. We might be avatars. So nice. Yeah, go ahead. You were about to say something, Mike. Oh yeah, sure. So yeah, hello again, everyone. I see like some folks joined. We can slowly start. I believe the rest will join along the way. Thank you very much for attending the first session of our webinar series on generative AI applications. So in this session, as well as the next, we will discuss the research agent, which is a real-world application of agentic workflows. The presentation will be led by myself, Farhad Davaripour, and my colleague, Mike Morley. Just a few housekeeping items. If you have any question, please put that on the Q&A. So we have two spots during the presentation that we answer to any questions. Also, please keep an eye on the chat because if you want to follow along especially for the demo and for running the notebooks, so the link to the notebook and the demo will be provided in the chat. So you can just simply click on it, but I will also show you how to find that. And additionally, here is a brief introduction to Arcurve, the host of this webinar series. Founded in 2006, Arcurve is a technology company that assists clients with their technology and software needs across a wide variety of industries and projects. If you need to get more information, feel free to visit arcurve.com or basically follow Arcurve on LinkedIn so that you basically get notified of all the updates, especially like these webinars. So with that introduction, let me just speak a little bit about my background. So I currently work as a lead data scientist at Arcurve. By training, I hold a doctorate in civil engineering. However, I have industry experience as an MLOps developer. I've built large language model applications. And also, I have done quite a lot of simulation, especially in my expertise, which is on the pipeline, like subsea pipeline and buried pipeline. And in my free time, I enjoy playing ping pong, mountain climbing, and traveling. Also, I like making sushi and eat them. I like that a lot. And I believe they taste really, really good. And so at least that's what my wife says. So I hand it over to you, Mike. Just some background about yourself.
Yeah, I also come out of an applied engineering background, geological engineering originally. But I got into the machine learning domain pretty early on in my career, helping to develop a two-dimensional mine modeling blast simulation engine, and then traveled across Canada, setting that up at different mine sites and whatnot. And then since then, I've been working in this sort of applied domain, applying technology to solve various different types of real-world challenges and building models of physical systems and things like that. 2016, I co-founded a company called Menome Technologies, which was then acquired by Arcurve, and we now have a really great team that focuses on applying, understanding and applying AI to the world of business to solve difficult challenges that are out there. And I also enjoy spending time in the mountains and mountain biking, playing a bit of music. I am not known for my culinary talents, though. So, I'll eat Farhad sushi. I will not subject anybody to any sushi that I make.
Fair enough. So awesome. So as for the agenda of this presentation, we will start by discussing the business challenges that enterprises face. Then we will introduce Agentic Workflows, a promising yet underutilized solution to streamline tasks and simplify complex business processes. Next, we will explore a specific type of AI agent called a React agent, showing you how to develop one from scratch and demonstrating a simple use case. And finally, we will showcase the research agent, which is an advanced application of a React agentic workflow. So now I hand it over to Mike to discuss the business challenges and provide an intro to the agentic workflow.
So this is a super interesting and a pretty exciting domain to be in right now with the advent of the agentic AI. And the reason for that is that in the many years that I've been involved in this domain of trying to take business processes and automate them and augment people's abilities to kind of focus on the real work that they need to do without having to get mired down in things like expensive approval processes and invoicing and all these kinds of things. The fascinating thing is that even something as simple as an expense submission process, and I know probably everybody on the call has gone through these sorts of things, these processes become pretty complicated very, very quickly. And it's the little nuances and details that are associated with these processes that actually make them pretty tricky to write software for. And the reason for that is that even something like an expense approval process, so let's just talk about that for a second. So you have the expenses come in all sorts of different sizes and formats. And as you know, probably more recently, we've been able to use various different types of AI to extract data out of expense receipts in a more automated fashion. But even subtle things such as dates and date formatting can throw these types of static or logic-based workflow processes off. Another piece of the equation that falls into this, where the AI, the agentic AI in particular, starts to be able to help with this, are the rules around these processes. So in a case of an expense workflow, for example, you may have an approval threshold that you put in an expense, and there's a certain group of people in the accounting department or whatever that have to review the expenses and approve them. The challenge with that is if you've got an expense that comes in that maybe is a little different and doesn't quite fit into the rules pattern that have been established by the developers of these various different ERP or accounting systems. A simple rule change or a simple exception like that can become a pretty big barrier to these types of processes actually being able to do their job. So for example, if somebody in the approval stream was away and the agent or the rules basically said, okay, send this expense to this person, the logic starts to fall apart pretty quickly in terms of trying to be able to handle edge cases or exceptions like that. So what these agentic AI agents are capable of doing is you can have that sort of stepwise process that walks an expense through step one, capture it, step two, submit it, step three, assess who it needs to go to for approval, and what thresholds are involved in that. But you can also condition each one of these steps now and augment them with these little AI agents. And Farhad's going to take you through what that process actually looks like in terms of how you tell the agent at what step and how it should think about the tools that it has available to then make a decision to proceed forward. And the nice thing about that is, as you know, of course, large language models have the tendency or can hallucinate or generate things or go out of bounds of what they're supposed to do. But by using this agentic pattern, you can actually condition these agents to use and only use certain tools and then make decisions about which tools they need to use to then take an action to then move a workflow forward. So let's go to the next slide. So the capabilities that come into the equation that are particularly important here are ones in which, as a programmer, usually what you do is you sit down and you go, okay, I have to figure out all of different possible permutations and combinations of a decision that needs to be made. So if then branch logic, these types of things. What happens now is instead of having to try and figure all that stuff out, we can bring, using these agentic capabilities, the power of a large language model in to do things like, let's say somebody has a question about a thing about a policy or a procedure inside of a company. Well, these agents can now, you can basically define tools that have access to the different resources and systems inside of an organization, and then instruct the agent to interpret the question and then figure out which tool is the most appropriate one to answer that question given the way it interprets and understands the nature of the question. In the past, doing that was extremely difficult because you, as a developer, you'd have to try and figure out all the different ways a person could possibly ask a question. With these agents, you can actually condition the agent to say, take the nature of the question, and based on the way the question is formed and the way you see the question, pick the right tool to get the answer to that. This then also helps accelerate the development process because, again, as a developer, I don't have to come up with every possible context or every possible permutation of thing that way a person might ask a question. I can just set the conditions up, set the tools up, and then tell the agent how it's going to take the question and the things it needs to do to then move to the next step. Next slide. And this really, at the end of the day, there's a couple things that come out of this. One, it really reduces the developer workload. So as I mentioned, you don't have to sit there and try and figure out every possible thing could happen. The other thing that's really nice too is if a workflow process or an exception or some other thing that you haven't foreseen occurs, the agents can still handle a lot of these different cases that come up. So it makes them a lot more robust. The challenges, of course, are making sure that the agents are working within the defined process boundaries. And you do have to make sure you think about the costs associated with developing these types of systems, and also the way you're going to test them to make sure that the agents are in fact responding and working within the boundaries and context that the developer and the organization intends. Next slide.
So great. I can take it from here. Thank you very much, Mike. Now, with this introduction, let's explore and build an agentic workflow from scratch, which is basically one of the primary goals of this presentation. So in the following slides, we will explore a specific type of AI agent known as React Agent, which stands for Reasoning and Acting. So the React Agentic Workflow is an effective approach for streamlining business process while maintaining transparency and accountability, so that Mike touched on. So which are the key challenges when implementing Gen AI in any form at the enterprise level? So what do reasoning and acting mean? So reasoning involves breaking down a problem in a smaller parts and using a chain of thought to address each part step by step. For instance, if the goal of the query is to move from point A to point D, the agent first identifies the path from point A to B, and then B to C, and finally C to D, tackling each segment individually and feeding the results of each segment into the subsequent step. A key aspect of reasoning is that each part of the problem is mapped to a specific predefined tool or function. So, I mean, just to like echo what Mike said, it provides a lot of control and transparency around the workflow. This is basically where the acting component of the React agent comes into the play. If you remember, it was reasoning and acting. So the acting would be executing the necessary actions based on the reasoning process. So all these will be very clear when we go through the demo and basically we develop one of these agents from scratch. So just to like basically emphasize, so this approach adds significant transparency to the process, because unlike directly using Gen AI, which is a black box, we break down the problem into manageable smaller parts and use predefined tools or functions. And so we have developed them, so we have full control over what we need to generate, and so we can also check that. So, and by basically like using these tools, each part could be executed. And so, I mean, as we mentioned, so this basically tackles the main concern that we have in using Gen AI. Before getting into like so much details, so let's start by checking out a demo. So this gives us some context about basically how a React agentic workflow would work. So you can either go to GitHub under my name, and this is basically the first repo. And in here, you should just you need to click on the Open Streamlit, or alternatively, check out the chat history. And this would be the first link on the chat history, link to the demo. So just by clicking on that, so you will be directed to the demo that we're going to go over. So basically in this demo, we are going to go through a simple problem. So this is simple enough so that, I mean, we basically understand how the whole workflow works, but it also has some components that are involved within a React agentic workflow. So let's go through the problem statement. So this example simulates a project management scenario where we need to allocate resources to various tasks. So the React agent will help us assign resources based on task priority and the resource availability. So it has to check these two. So we need to provide to the agent the tasks and the resources. So each one of them is going to be under a tool or function. So the agent should find a way to map the query, the question, to each one of these tasks and then run them in order to have access to either the task or the resources. So in a real world scenario, so these tasks or the resources will be in a database, or it needs to like call an API just to be able to retrieve these tasks. But in this particular example, we keep everything predefined just for simplicity. So now let's run the question. And so when we run the question under the hood, it goes through all those reasoning steps, and then it come up with the final answer. Let's check the final answer. It says the resources have been allocated to high priority task. Elena has been assigned to implement machine learning task for 40 hours. So it has to have availability more than 40 hours. So we check out Elena, it has 45 hours availability. So that makes sense. And then for the other one, Sophia has been assigned to design user interface task for 30 hours. So if we check Sophia, it has 35 availability. That makes sense. And these were like a 2 high priority tasks. So it did what it was supposed to do. But if you see, it's a very easy example. So if you just directly give it to a chat GPT, it's able to handle that. But the main thing, in addition to the fact that if the problem is complex, in most cases, like direct like prompting won't work, the main thing would be the transparency that we get from like all these intermediate steps and the control over the whole process. So I'm going to go over the reasoning step, and once we have some clear picture, we talk a little bit about details, and then we start developing the whole workflow from scratch. So the first part, I mean, the core part of a React agentic workflow is the memory. So the React agent, along the way, while it's doing the reasoning part, it always has access to every step before. So these steps start from system prompt, then it goes to all the other prompts that we'll talk in a little bit. But the initial prompt or the initial part of the memory that it has access to is the system prompt, which is a set of instruction that tells the React agent how it has to be behave, it has to act. So basically, this is what turns an agent into a React agent. Basically, in here, we tell the agent you have to run in a loop of thought, action, pause, and observation. And once you're done, you have to come up with an output, which is the answer. So then we provide an explanation about what is thought. So effectively, thought is what's been generated by LLM. In this case, we are using OpenAI. What's been generated by GPT-4o is your thought. Then in your thought, if there is an action, so if you have mapped your thoughts to a particular tool, then use the action to run one of the actions available to you. So which means that we have to introduce to the agent what are the tools that are available to you. So you should always use the tools that we tell you to use. And then there is a pause. So pause means at this point, you shouldn't generate any more thought. You should wait for the results of that tool. So which means that we are looking for the observation. Observation would be the result of running those tools. And it will go through the loop of thought, action, pause, and observation until we get to the point that it doesn't require any further action and it can answer to the initial query without executing any more tools. So in the system prompt, we have two additional components. One is we need to introduce what are the tools that are available to the agent. So typically, like in a production level app, we have like a variable, and this variable will provide basically the set of tools that are available to the agent. But for simplicity in here, we are hard coding the tools. So basically these tools are retrieve tasks with the argument priority level and retrieve resources. So because it needs just these two in order to answer to the problem that we have defined in here. So the other components that basically help the agent to learn how to behave or how to act is to provide a set of examples or just one example. So this is like a technique in prompt engineering called like either like one-shot learning or three-shot learning, and it basically helps us to provide some context and train the agent to like answer to the query in a certain manner. For instance, we provide like a similar like set of question, thought, observation that we are expecting agent to basically generate when we ask the question. So this could be a static or this could be dynamic, but for this problem, we keep it static. So we have a static system prompt that comes at the beginning of the memory. And the next prompt that's going to be appended to the memory would be the user prompt. That's actually the query that the user is going to ask. So in this case, the question was allocate resources to high priority task. So and now like it has access to these two prompts. And then the next step would be to execute the LLM, to invoke the LLM based on these two prompts. And then the LLM uses the system prompt and the query, and then it generates this thought. I need to allocate resources to high priority task. First, I will retrieve the high priority tasks. So basically it understood that in order to solve this problem, you have to split it into smaller pieces. And your first piece that you need to solve is you need to figure out like what are the high priority tasks. And it basically generates this action based on the like available tools. So it says that we have to run this tool, the retrieve task, and this is the argument that needs to be passed. So like the priority level has to be high. So as you will notice, like after the system prompt, we have two types of prompt. It's either the user prompt or the assistant prompt. Assistant prompt is what's been generated by LLM, and user prompt is either the query or is what's being executed by the function. For instance, in this case, when we execute this function, retrieve task based on this argument, it will be stored as a user role. And this is what's been returned to, what's been appended to the memory, which is basically available to the agent. So once it has this, then it will generate another thought. It says, okay, now I need to retrieve available resources to see who can be assigned to this high priority task. And it also mapped this thought to a certain action, which is retrieve resources. So like before, it basically execute this function. It will return all the resources because we haven't filtered the resources. It basically return all of them. And then finally, it says that I've identified two high priority tasks, to implement machine learning and design user interface. And then it finds out that Elena has a skill in the machine learning and 45 available hours and can be assigned to the implement machine learning model task for 40 hours. And the same goes with Sophia. So it does the same assessment. And finally, it comes up with the coherent answer to the initial query that was basically submitted by the user. So as you can see, we have the full control over what should be executed and how it should be executed. And this basically is what's been required to use Gen AI at the enterprise level, which is the reason that we basically picked the React Agentic Workflow for this presentation. And now with this context, let's go through a little bit details about the workflow, and then we will start building the same workflow from scratch. So I'm going to get back to the slide deck. And here we would like to, and here we would like to talk about what are the steps involved in this agentic workflow. So when the user query has been submitted, as we discussed before, we have the memory, which is one of the core components of the React agentic workflow. And this user query will be appended to the memory. So the memory already has the system prompt because that's the instruction that's required for the agent to know how to act and how to reason. And then the next prompt is the user user query. And once it has these two components, then it generates a thought. So the next basically component would be a node to assess whether the thought has an action or it doesn't have an action. So if it doesn't have any action, for instance, in this case, it would be the last step. So if you remember, the last step would be the step that the thought that's been generated doesn't have any action with it. So this is the step that it basically breaks the loop and it returns the final answer. But if it has action within the thought, then it needs to execute the action. So, I mean, this is the function calling. That's what, I mean, this is one of the features of all the modern LLMs that are able to map certain basically like prompt into like a relevant function. So basically map that and then execute that function, which will result into an observation. And the observation will be, again, appended into the memory. So as you can see, as we go through this loop, the agent constantly has access to everything that's been basically processed, and nothing will be overwritten for this particular example. So, I mean, there are scenarios at the production level when we want to ask many questions. So there are cases that we need it to be overwritten, but like for simplicity, in this particular example, we are going to ask one question. So and everything will be just appended. An agent has access to everything. So just to go through the components that we just went through, we need the memory. So agent has to have access to all the prompts that's been generated. And then we have the instruction, which is the system prompt, the logic that the agent needs to reason and act. And then we need the set of tools. So these are the actions that we need to define. So either we can use some of the predefined tools that are available. For instance, Mike, when he goes through his demo, he will show you that. So we can use one of the predefined tool just to search the internet, search external sources, or we can also develop them ourselves to have the full control. And finally, the workflow will be the loop, so that we have to develop a logic so that it basically does this iteration over and over until it gets to the point that has the final answer. So with this introduction, now I'm going to go back to that GitHub repo, the React agent from scratch. And instead of clicking on the Streamlit button, I'm going to click on the Colab, Google Colab one, because we want to run the code within the Colab environment. So you can either just go through the same process as I showed you before, or you can just simply click on the Google Colab link from the chat that Tiana put on the chat. So one important point for those of you that you are following a line and you want to be able to run like each cells, you basically want to have access to API key. If you have the API key, you can just simply just go and add it. But if you don't have it, simply just go to the secret. And in here, you need the name and you need the like API key. So this is basically the API key that you can use. And it also is in the chat. So both the name and the API key is in the chat. Just simply go here to the secret and just copy and paste that. And then you will be able to follow along. So assuming that you have done that, basically the first step would be to do the setup. So while it's basically installing these dependencies, I'm going to just show you like what are the steps. So first we do the setup, then we go through the system prompt again very quickly. Then we talk about the tools, and finally we go through how we do the execution. So basically it needs to install the OpenAI, and for those of you that you want to just clone the repo and you want to run that locally, you need the Python .env to be able to load it. For you, if you want to just use it locally, just uncomment that and then load that from .env file, like the API key, and you should be good to like good to have the OpenAI activated to work for you. So the next step after getting the API key from the environment would be to to have the client to initialize the OpenAI. And afterward, as I said, the immediate step for the agent would be to have the system prompt. So this is basically what we went over. A set of instructions, the available tools, and finally an example for the agent to know in which format we wanted to generate the answer. So that's basically the same thing that we went over. We want to just run that so that it has the system prompt within the system prompt and variable. Another piece that, that's quite important is that, we also discussed is the agent class. So we defined it within the agent class. So it has two main functionality. First, it has the memory, basically initialize the memory. And every time that we are running the call method, what it does, it will append what's the prompt that's been generated or submitted to the memory. So the prompt is either the user prompt, which is either the query or the observation by the execution of the function, or the prompt is basically what's been generated by LLM from the execution. So both of them are continuously being added to memory, and the memory will be passed to the LLM to generate the thought. And that's how agent always has access to the memory, because we always keep track of every new prompt that's been generated. So we need this agent. Let's run that. And the next step would be to define the functions. So I briefly mentioned that in a real world example, in a use case, we typically need to connect like the tool to be able to do like an API call and fetch tasks or resources. But in here, just for simplicity, we have some predefined task and predefined resources. So we are expecting that if the agent identifies that it has to run the retrieve task function or retrieve resources function, it basically just returns like the predefined task or resources. Only for the predefined task, we have the argument. So it could be high or medium or low. And based on that, the task will be filtered. And this is the final piece that's been required for a React agentic workflow. And this piece is, does two main tasks. What it does for us, it will create that workflow for us. So it goes through the iteration until it breaks and there is no further action required. And for that, it needs to initialize that agent class. And then that agent class will be basically executed in each loop. And so once it's been executed, it will generate the thought, and also the memory will be returned. But basically, in addition to execution of the agent, another important task that this query function has is to look into the thought and see if there is any action in it. So simply what it does, it will use the regex. So this is a pattern from the regex. It will go through this pattern and figure out if the thought has any word action in it. And then if the actions list has some value in it, it effectively means that so the thought that's been generated by LLM has an action. So, but if the action doesn't have anything, which means that we have got to the final answer, and that's the point that it will break, and it will basically return the final answer. So provided that it has an action, then so basically it will return the action and action input, and those actions and actions input will be executed in this step. So we have a dictionary known actions that we will pass into the query function in here. So the known actions are either retrieve task or retrieve resources in here, and based on the action that's been identified by the thought and the action input, then we will basically execute them. It will be stored within the observation, and the observation will be saved within the next prompt, so that the next time that we run the agent, we basically add the next prompt to the memory, and we will also invoke the agent, the LLM, to generate the new thought. So it will go through this loop. So as you can see, the whole process is not very complicated. The main thing is just having the query set up and the agent class set up. But all the popular, basically the two main popular packages that are out there, the LangGraph and the Llama Index, what they do, they basically streamline the process. They take care of this workflow, and they take care of that agent class. So your main basically attention would be on building your own tools. So that basically simplifies your process, but it's great to have a fundamental understanding of what's going on under the hood. So once we have the query function, then we need to set up our tools under the known action dictionary. Then we will have the question. We need to define these two arguments, the model type, which is GPT-4o, and the max turns, which is 5. So we typically with GPT-4o, you should have enough, logic and capability to be able to run these kinds of React agentic workflow. And when we run the query with the question and max turns, that effectively is our agent. It will basically, as we showed before, generate the thought. It will find out the first one is retrieve the high priority task. This is the action, this is the argument. And basically what it needs to do is that it will need to run this action with the input high. And the observation would be basically the two tasks, they have the high priority. And then it will generate another thought. This time the thought would be to basically it says I have identified two high priority tasks, implement machine learning, blah, blah, and then it will come up with another task. It needs to retrieve resources. So it will run retrieve resources, which is another tool that we have defined. It will return the observation, which is all the resources, and then it has everything that it needs. So at this point, we will get to the point that there is no action in the thought, and it will directly go to the final answer, which is the resources have been allocated to high priority tasks. So, this is the memory. So the first one is system prompt and the user prompt, which is the question, and it will go through the system, the assistant, and the user prompt until it gets to the final answer, which is the thought. And yeah, this is basically the final answer. So basically this was, if you go through this process a few times, you will find it not very complicated. But this is a very powerful tools, and basically you can yield very significant results for that. So I'm going to basically pause for a few minutes if you guys have any question. And if not, I mean, we can always answer the question right at the end, but we can pause for like a couple of minutes if you have any question before going on with the rest of the presentation. So I still haven't seen any question in the Q&A or in the chat. I believe, I mean, some of you might have kept your question for the end, so that's fine. I think we are good to go with the following slides. So I see a few questions coming. Maybe I can answer those two, and then so I will answer these two, and then we'll go on with the rest of the presentation. Do you have the valuation of these demo? So that's a great question. So I mean, right, any other technology that we basically like build some evaluation around that. So we can build some unit tests for each one of the tools that we execute. And if the tools also requires to like use some underlying technology, for instance, like the one that Mike is going to use, like a RAG, we have some, I mean, semi-best practices in order to evaluate those workflows. And also for the LLM itself, as I said, there are not like a best practice that this is basically like the way that you need to go, but there are like certain recommendations in order how to evaluate the relevance of the final answer with the initial query, because we should always like check them against each other. And if there is like some information that's been retrieved from the internal or external sources, we should always make sure that those contexts are relevant to the initial query. So that would be another evaluation. And so we can basically have for each one of these steps or for each one of the tools, we can, based on like what the tools is going to do, we can define different evaluation pipelines. And so and this is basically very flexible. I mean, because it's not like a RAG agentic workflow. This is basically a React agentic workflow, and it could have many complex process underneath. And another one is, I'm wondering, what are the other applications for React? So it could have any application. So for instance, one of them, the mic is going to go pretty quickly right after this. But basically, think of any workflow that's very complicated and it needs to be broken down into smaller pieces. That's where React Agent is going to shine, because they are able to split it into smaller pieces and then run some functions that we have defined. And basically, there is no pre-built function for that. So that's where the React Agent would shine. So I will keep it short because we don't have a lot of time. And so I hand it over to you, Mike, and we can get back to the question right at the end.
Thanks. Yeah, so building a bit on what Farhad has been saying and illustrating is, yeah, these agents are quite powerful in terms of being able to take typical workflows and making them a bit more flexible and fluid. The example that I'm going to show here, and we're just going to go through this at a very, very high level. It's something I've been working on for a little while now as both demonstrating this, but also demonstrating the elements of the technology, but also it does have a very specific use case that I'm applying it to, which is helping people with functional memory challenges access the knowledge that they've built up over their career. So in the case of this particular setup, I've got a bunch of documents that the person in question has written. I've taken those and I put them into the structure that's required to ground an LLM in what they call a RAG, or retrieval augmented generation pattern. And in this case, I'm using Neo4j graph database. I then have written a GPT, which sits inside of the ChatGPT environment, that talks to an API that I've constructed that lives up in DigitalOcean, that connects the GPT. So when the person goes into they can bring up their phone, they can then interact with the knowledge that they've got stored in this repository without having to find the files and without having to navigate file folder structures, without having to use SharePoint or any of these sorts of things. They can just ask a question and get an answer back. In the case of the way this is set up, though, with the help of Agentic AI, what we've done is because the person's writing their memoirs, so they may not have all of the information that they want or need inside of the knowledge that they've written over time. So what we wanted to do is have a couple of other sources that the system can then refer to go and get the knowledge if it doesn't happen to be in the repository. So we've constructed a set of tools, and one of the tools assesses whether or not, and I'll just jump to the next slide here in the interest of time. We've got a tool that classifies the question. So if the question is very specific, it will then direct or pick a tool that's specially designed to answer specific questions. If the tool, in the opinion of the agent, is more broad, it will then open up to a different set of indices and a different set of libraries inside of or documents inside of the retrieval augmented generation database that's set up to answer more general questions. If it can't find the answer through those two sources, it will then go out to an external source to find that. And it goes through essentially this decision action pattern, action observation thought pattern to then select the correct tool, get the results back, take the observation as to whether or not the results actually help answer the question properly. And then if it does, it synthesizes the response and outputs the information. So let's jump into a demo. And okay, so on the one side here, we've got the GTP that lives inside of ChatGTP. And on the other side, we've got the output log. So let's ask a question. Now, what we should see here is we should see this is talking now to my API that's hosted up in the cloud. You'll start to see the agent kick into gear, and it's starting to run the processes, and it's assessing the question. It will then spit out some output. Here we go. And what you'll see is that thought, I need to determine whether the question, what is Landgraph, is general or specific. So in this case, it's assessed the fact that, yes, this is a very specific question about Landgraph. It will then proceed with using the internal specific answer search tool to find detailed information about Landgraph. So the cool thing to note here is that this is the tool making the decision on its own. I provided the guidelines for the agent to make the decision, but I haven't told it to use a specific tool. It will then go out and find all this information, and then it will decide whether or not it has sufficiently got enough data to answer the output, and then it will synthesize it and put it out with the sources. Let's try a different question. And what we should see happening here is as this goes through the process, we should see the agent likely decide that this is a more general or broad question. So it should go down a different decision path. It should pick a different tool. Let's see what it did. So in this case, I need to determine whether or not the question is general or specific. It has decided that, in fact, this is a general question, which it is. It then uses the other tool, which is set up to handle answering or getting information for answering that type of question, and then responds accordingly. Now, for the final magic trick, I'm going to ask a question about some information that I know is not in my repository. How does it compare? And I'm going to answer a bit more of a complicated question. React agents. So in this case, this question has two parts to it. And I also know that in the case of this, I don't have information or shouldn't have information in my repository about Super Agent, because that's a different library that I haven't worked with. Now, what we should see here, the question, you can see the thought, this is awesome, is asking about two different types of agents, Super Agent and React Agent, and how they compare. I need to classify the question, so it does that. So now it's searching through the different tools that it has at its disposal. And you'll notice up here, answer. I don't have enough information to provide an accurate final answer is, and how to compare it. So then what it does is the agent will go through thought. The internal specific agent answer did not provide sufficient information on super agent. So I need to go to the external search tool to find information on this. Now, the really cool thing with this is you'll also notice that the agent was smart enough to retain the information from the internal search tool because it actually has information regarding the React agent, which I do have in my repository. So then I can also, if I'm the user kind of sitting on the GTB side, I can ask it, how did you come up with this answer? List thoughts, observations, and tools. So now I can actually see the exact process that the agent went through, the strategy that it used to answer the question, how it did the comparison, the tools that it used, which also gives me the sources and all of that. So you can kind of see the way that these things are going. This is an extremely powerful paradigm. You can imagine writing tools for all the different systems inside of your organization, and then having these agentic workflows set up in such a way that people can start to interact and get information, know where the information is coming from, understand how the tool has made or the agent has made the decision, which tools it's selecting to actually synthesize the response, and then having the flexibility of the tool to actually, or the agent to actually figure out, even if the question is a little different from one it's seen before, it can figure out the best path to try and answer the question at hand. And I think, speaking of questions, it's time for questions.
Yeah, just the last piece of like we have one like references and resources that we can also show, but we probably can wait for that right to the end. Yeah, these are the resources, especially like the AI agency in LangGraph. The second one would be a short course within deep learning AI. So that's recommended. Just if you guys are interested about React Agent, it also provides like great information. So you can check that out. And also like some of the info and some of the parts about the demo has been also retrieved from the AI agents in LangGraph. But yeah, these are great resources if you want to get started. And in response to that question, can I open my mic? Unfortunately for this session, so just ask your question in the chat or Q&A, and we will respond to that. Can you share the source code for the second use case? Mike, this is for you.
Yes, so our intent here was to use that second use case as a bit of a teaser. And yes, so what we're going to be doing is we will be going through in more detail that example that I was illustrating in subsequent lectures. Our plan is to, as we go through kind of, there's a lot more you can do with these agents. We've got examples that go through a research agent, which basically you give it a directive and a topic, and it will go out and actually collect a bunch of information up and then generate a newspaper-like output from it or a Wikipedia article. So yeah, we're going to step through a bunch of examples on this, and then yes, at the end of that, we will should be sharing the source code. My plan is to publish that system actually coming up in November. I do need a little bit of time to kind of go through and clean up some of the things, though, as I sort of figure out and how different parts of it work.
Yeah.
So stay tuned.
Yeah, exactly. So that was a good question and on time. So I mean, one question that I'm pretty surprised nobody has asked is that does the API key will expire after the webinar or not? So the answer is yes, it will be expired. So because I mean it's from my credit card, but yeah. So there's another question. I'm interested to know more about the evaluation metrics, which provides reliability. I would appreciate if you could give me specific suggestions. I provided some overall, basically like suggestions. Mike, do you have anything to add to this?
Yeah, that's an interesting one. So there's a couple of different patterns that are emerging for that. One that I've been working on, I think there's a person named Thomas Britannic has actually published some information on this exact subject. He does a lot of work on the Neo4j side, but also does a lot of Medium posts. So we can probably get a reference to one of those. I don't think it's in the current list, but one of the ways I've started doing this is basically I have a set of questions set up, and then I have the tools and the sources. And in the case of even this demo, for example, it'd be a bit like that, but an automated version of it where I'd set up a unit test that basically that is hitting the API endpoints, and then looking and inspecting the results that come back, and then doing a comparison against the results that are expected. There's other ways I've seen of that done where you can actually do it at a larger scale, by analyzing sort of more the questions and answers and interactions that go on through the API layer. But the trick is really having that API layer defined so that you have then something to test against, and then working with that.
Yeah, so I actually like this question because that's the main thing. So if the main point would be if we want to use that at the enterprise level, we should be able to evaluate that. So one suggestion that I would have is that, so the Azure AI Studio, which is still in the preview version, so it has a lot of features in preview version, but what it has done, it has like evaluation feature that has some predefined like evaluation metrics for you. So based on the typical workflow that you're looking for instance, if it's retrieval augmented generation, or if it's like other types of LLM-based applications, it will provide some predefined metrics and it will streamline the process for you. That would be the great place to start. And then, so once you have that set up, then you can just play around based on your specific use case and add some additional evaluation to that. So that would be what I do when I build a production level applications. I will start with that, then I will add some additional layers by myself. And the good thing about that is that once you build that within the Azure AI Studio, then you have all the code, you have everything that you can set it up locally. You just don't need to stick to that studio. You can just run that locally and just use the resources from your, whatever your cloud services is. We are running out of time, so I'm going to go to the other question. I thought that the agent does an academic research. How far we are from automating academic hypothesis generation and testing the hypothesis? So, Mike, are you gonna just answer that one? That's related to your part about the research agent.
Yep. As I mentioned, I do have a basic research agent. I would say we're quite a ways from it fully being an automated process. The way I tend to use this thing is whenever I read something, I store it into the system that I was showing. There's a little method I've got for that where I drop the article reference in that gets run through the process. So then I capture basically everything that I read. It's one of the ways I keep tabs on how on the rapid development and evolution of all the AI things that are going on. That can do basic answer, synthesis of outputs and articles, which I do use when I'm writing blog posts or other things like that. I'll actually use that tool that I've written to say, I'm writing a blog post on blah, blah, blah. What sorts of sources do you have in here? Synthesize that into an article output, which it will do. But it's nowhere near the level that would be required at this juncture for generating something at the level of an academic research paper. It is very useful, though, for enumerating, articulating, or discovering sources in dense repositories and whatnot. And I do have it set up, as you started to see there, where it can go out to different places and start to source content that is related to things that I have in the repository or to a subject or topic that I'm interested in exploring.
Yeah, so the last one is a challenge with agents is ensuring they stay within boundaries. One wrong action can throw off the whole process. Have you looked into that? Any recommendations or best practices other than more accurate prompting? So of course, you definitely need to experiment, but like any process, so basically it can be like exposed to error. And the best way that we can basically make sure that it's doing what it's supposed to do is by having some monitoring system in place and then monitor those like evaluation metrics that I've set. And by the time, if it's within the boundaries that's acceptable to the business, then we are okay with the process. But it's always prone to errors and just basically, as you mentioned, and not mapping that to the right function. Especially if the initial query is not clear enough or it's pretty vague. Or, for instance, like I remember, Mike, you were mentioning about one use case that it was not able to find out if the query is like a vehicle or like something else. I don't recall what was the query you were experimenting with. But yeah, there are some cases that you can really confuse the agent.
So the other way you can do that too is you can take the more you break the workflows down into smaller elements, and this is where LangGraph comes in. We only touched on that today, but we'll go into it, I think, in later sessions. But if you start to reduce the scope of what the decision that the agent has to make, and then you're providing it the specific tools that you want it to use within the context of that scope, that helps narrow the potential drift that can happen at each node branch. So this is where some of these new patterns that are coming out that are pretty interesting, LangGraph being just one, but they allow you to use a combination of deterministic steps with these agentic decision points along a path to then get to an objective. So then you can choose, as a developer, you can start to balance out the probabilistic pieces of the thing with the steps you really want to have happen in a certain order and this kind of thing, while still leveraging the power of these types of systems.
So I think we are running out of time. Thank you very much. I appreciate everyone for attending this session, and stay tuned for the next one. And yeah, thanks, Mike, for like putting that in the chat. Is there anything from your end, Mike?
No, I just pasted a reference. So there are a number of organizations that are working on the testability of these things. There's a system that's been published by the LangChain guys called Langsmith. It does allow you to do monitoring and testing. It's still pretty new, so I haven't had a chance to explore it yet, but I put that in the chat just for reference for folks if they want to check it out.
Awesome. So thank you everyone for joining. I appreciate it, and see you at the next session. Take care.
Thanks.
Thanks. So I suppose we just need to leave.